We'll give it just a few more minutes here, Katie. Okay, why don't we go ahead and get started. So good afternoon, everybody. Thanks for joining our breaks today. Today we've asked the directors and managers of all of our core facilities to come and just provide a brief overview of each of their facilities and capabilities in them. So these are all facilities that are managed by the Division of Research directly and are open to all faculty on campus who may want to use them. But I also know that not all faculty know that these facilities exist. So this was a good opportunity just to give a quick overview. I'm going to ask each of the core directors to just introduce themselves when their time comes up. So we'll have the short presentation and then we'll take questions here at the end. So we're going to start with our genomics facility and Dr. Lee Hughes, who is director of that group. And I'll turn it over to you, Lee.
Thanks, Aaron. Give me just a second. I'll get this shared. I think I shared the wrong screen. Give me 1 second here. I have 3 screens, so it's really, it makes it fun. No, it's showing the other one.
Yeah, I think it was the right one.
Was it the right one? It doesn't show on my side. Okay, okay. Sorry about that. And they're also not in order. They go 2, 3, 1. So, as Aaron said, I'm Lee Hughes. I'm the faculty director for the Genomics Center. Right now, we do not have a center manager. We're between managers. Some of the things I'm going to show you are not going to be available until a new manager is hired, but I will let you know that as I go. So just some of the things about what we can do with this. We provide next generation sequence data, but at the Genomics Center is also a place where your students can get training on how to use some of the equipment. And then there's also opportunities to collaborate with equipment at other institutions that we don't have on our campus, that we can provide other connections to those services. There's a number of machines that are available for this. It can get us through the basic sequencing workflow. We can provide services for library prep, sequencing, analyzing, and transferring the data. And this includes our MiSeq system, which is good for certain sizes of runs, a little bit smaller runs typically. I'm not going to spend a lot of time on each of these slides because we've got a lot of centers to get through, but I'm just kind of giving a quick overview. And I can make the slides available as well after if anybody needs them. The other system we have is the NextSeq system, which is going to do larger runs and can gather more data at a time. And we will have access to larger sequencers at other institutions like UNT HSC, where we can collaborate with them. So, well, obviously, these are things that are not going to be available until we have a manager again, because this equipment requires a lot of upkeep and training to use. We do have some other instruments that are also available, and if you've got students already trained, or we can I'll say at the end, Aaron is actually going to be the contact for using some of these things that are available in the Genomics Center, including things like a qubit for quantifying, your DNA, RNA, proteins. We have access to a bioanalyzer for analysis of fragments and genomic DNA analysis, and some liquid handling robot capabilities as well. So those are things that could potentially be used now if a person has appropriate training and can work through with Aaron to do that. And that gets me to my last slide, which is there is a website for the Genomics Center. You can go there. The website includes things like give you an idea of what pricing looks like. There is internal pricing for UNT users, and hopefully we'll be moving soon on finding a replacement manager and get all the services back up and running in the near future. All right, I think that's everything I had at the moment. I'll be available for the question and answer part later, but I think at this point it's Anna's turn.
Thank you, Lee. Let me see if I share the right screen. I have 3 screens too, and it looks like it's a common denominator. I guess that's this one. Yes, share. So I'm Anna. I have this thing in the middle. Can I move that? Wait a minute. Here. So I'm Anna Alonso, and I'm the director of the Bioanalytical Facility. I'm also professor in the Department of Biological Sciences. And let me introduce you a little bit of this facility. So we are located in the Science Research Building, and we have a wet lab and a portion where we have all the mass spec equipment. So that's why we have 2 room numbers here. So a little bit of history about the Bioanalytical Facility. It was established in 2018 under the Biodiscovery Institute, and it was elevated in 2020 to University Core Level Facility. So we are under the Vice President for Research and Innovation. So what is in the BAF? We have state-of-the-art mass spectrometers that have advanced capabilities for separating and quantifying small molecules. And we receive a very diverse set of samples from microbes to all the way to mammalian. And so we do support researchers, internal and external users in the field of metabolomics. We receive samples, of course, from people at UNT, but also from companies, other universities in the US, and even abroad. So our mission is to provide access to these core facilities to all the researchers, and we do train them. Most of the graduate students and postdocs, they never really use a mass spec. So we are happy to train any new user for free. We assist scientists, PIs, postdocs in the design of robust analytical methods, and as well as how to process the data and try to interpret the data. And also, if you need any support letter for your proposal saying, hey, we have this capability here at UNT, I'll be happy to provide a support letter saying, yes, we can analyze these compounds here in the facility. We have experience, so that's supporting the proposal and your research for the funding agency. So here are the people currently at the Bioanalytical Facility. So this is me. We have a manager, Jean-Christophe Corcoran, who is 100% BAF. And we just recruited Yasmin Hilaris as a research coordinator. She's just started on March 1st. So that's the 3 of us. And I'm just going to make a couple of definitions to make sure we talk about the same thing. So the Bioanalytical Facility is a facility that analyzes metabolites from various types of samples. So a metabolite is basically an intermediate or product of metabolism, and is smaller than 1 kilodalton in size. So the metabolome is what we measure, is a complete set of metabolites. And when you do metabolomics, is when you want to quantify different metabolites in your samples. So I want to make sure that you all understand when we do have mass specs, but we don't do proteomics. So that's a completely different omics. We are contacted many times by several researchers who are looking for proteomics facility here. And as far as I know, unfortunately, we don't have this capability right now at UNT. But let me defend metabolomics. I would say that metabolomics is the omics that is sorry, Lee, that is the closest to the phenotype. As you see here, if you go to the genome of a sample, you have the DNA, and some of the genes will be transcribed and then translated into proteins, and then the proteins will be transforming a compound A into compound B, and we measure all these compounds, right? So we are the closest. We like to put ourselves as the closest to the phenotype. So in the bioanalytical facility, we have two approaches depending on the biological question you are interested in addressing. So we do targeted metabolomics, and we do untargeted metabolomics. So if, let's say, targeted metabolomics, it's to quantify specific type of metabolites in your sample. So if you know that you are doing a mutant, or you are doing a condition, you expect differences in sugars, well, we'll be focusing on the sugars. That's it. Now, if you do a treatment, or you have a mutant, you don't really know what is expected in terms of differences in metabolite profile. So this is where we'll do untargeted metabolomics, and that will give you the global metabolite profile of your sample. I'm going to show you a couple of mass spec equipments we have. So for targeted metabolomics, we have this LC triple quadruple from ABSAX. So you have the liquid chromatography part here and the mass spec here. They basically look like a big box, right? But we use it for targeted metabolomics. This is one of the most sensitive machines in the world. So whatever metabolite you have in here, it will detect it. For untargeted metabolomics, there are two approaches. You can do targeted metabolomics. Oops, sorry. You can do untargeted metabolomics using gas chromatography, mass spectrometry, which is represented here. And this is more for, you need to do a pre-treatment of your samples to be able to have your metabolites be more volatile, and you can analyze them by GCMS. And when we do this type of approach, we do have database that allows to give you a hint about what metabolites are in your samples. A little bit more, so this is another way of doing untargeted metabolomics, is to use this LC triple TOF. And this is the one I call the diva, because it's a little bit more finicky, but it's really useful. It is what we call a high resolution mass spectrometer. So you still have a liquid chromatography here, mass spec. This is a high resolution mass spec in the sense that it's going to give you the mass of your metabolites with a high precision. So you have a better chance to identify what they are. And of course, we have access to several databases to try to identify the metabolites that are in your sample. And I would like to end up with something that is coming soon, that we have this new LCMS that we are dedicating to lipidomics. So this machine will be to separate and quantify polar and non-polar lipids from samples. So I wanted to emphasize the fact that we are really here in academic setting to train students, postdocs. So we like to have them hands-on. That's really important for them, for their future research, for their CV. So we really are keen in trying to train them. And I would like to talk to you briefly about the course that I'm offering every year. It's currently offered right now during this spring. Actually, I'm teaching in 1 hour and a half. So where students, they come with samples. So this is for graduate students. They come with samples from their own research, and they learn about targeted metabolomics and targeted metabolomics. They learn how to extract and treat their samples, and how to run the machines and analyze their data. So that has been really great course to teach, and it's going to be having a real course number next spring. So it's listed here. So some students who took this class in previous years, they actually published their results in peer-reviewed publications. or some of the PIs actually use the results that were generated during the semester to submit as preliminary data for their proposal. And it's not because it's a bio number that it's not open to other people. I have students from the College of Engineering coming to take this class too, for instance, and from a health center too. This is the last slide. You can check the website. Here it is. Again, we welcome to come and see it by yourself. You can come to the Science Research Building and visit us. We are friendly. We try. And you have here my contact information. You have here the contact information from Christoph. I don't give you the contact information from our new research coordinator because she just started and I don't want you to scare her away. It's hard to find, but feel free to contact either Christoph and I or both of us. We'll be happy to address any questions you have. That's it. Let me stop sharing this.
Thank you. All right, Gil, you're up next whenever you're ready.
All righty.
Um,
See if I can get this up here. There we go. All right, my name is Gail Shadle, and I am the facilities manager for the UNT Core Greenhouse facilities. I just wanted to share a little bit about where we are, what we offer, and where we're headed. So the Core Greenhouse facilities are made up of 3 different greenhouse complexes. One is on the 5th floor of the Life Science Complex. There are 4 greenhouse cells there, and each one is approximately 400 square feet. So we've got approximately 1,200 square feet of growing space here. It is climate controlled. We have air conditioning and heating, shade coverings and supplemental lighting. Very nice. We just recently put together some auto irrigation systems and put in those rooms that are being used. That's going along quite nicely. Another greenhouse is the Science Research Building greenhouse. It is between the Science Research Building and the Chemistry Building. We just added 2 new cells to that a few years ago. We've got 4 cells in there. Each one of those are approximately 400 square feet. So we've got approximately 1,200 square feet of growing space. These are also totally air conditioned and have all the amenities. This also has a head house area where people can wash their pots, do their planting, take samples. It makes things a lot better for people to have that area to do those types of things in rather than having to make the messes inside the cells. And finally, our Discovery Park greenhouse facility is at the Discovery Park campus. It also has 4 cells, but these cells are approximately 1,000 square feet. So we've got about 4,000 square feet of plant growth area there. The ceilings are much, much higher than what we have in the other 2 greenhouses. These go about 20 feet. So it's perfect for growing large plants such as cotton and corn, and soybean, and all those things. It's also been used for small plants. Let's see, alfalfa was grown there for several years and did quite well. We do have a head house here also, and some storage area, which helps us store some soils. And everybody can do their potting and whatnot, and it's air conditioned in that part. The cells themselves here are not air conditioned like they are at the other 2 greenhouses. These have a evaporative cooling system, and we've actually just had quite a bit of work done there. We've been working on some renovations there and put in a whole new evaporative cooling system, and it's looking great. We are almost finished. We're very happy. So I guess we have about 7,000 square feet of greenhouse space. We have also hired a greenhouse maintenance technician. His name is John Sullivan. And he handles the repair and the maintenance for all the core greenhouse facilities. And things are going along smashingly. I couldn't be happier. I guess our mission statement would be that we work together to maintain the best, most healthy environment for the research plants. We have adopted a required plant identification labeling system. This is USDA APHIS compliant. Everything that's grown in the growth areas has to have a label. It needs to be properly labeled, whether it's in the greenhouse, growth chamber, growth room. We've got different colored stakes for different identification of whether something is genetically modified or wild type, etc. There are a few bits of information that have to go on these stakes. Spreadsheets must be kept to identify each and every plant and follow it from birth to death. And that has to be retained for 3 years by the individual researcher. They also have to be able to show their spreadsheet to any official who may ask to see it. So if we had some inspector from the USDA come in and want to know, is this plant genetically modified? Well, I would have to be able to tell from the color of the stake. Yes, this is genetically modified. It belongs to this person in this lab, and we can contact that person and the official can go and see whatever documentation they need to see. There are, of course, rules and regulations in all this. You have to submit a space request if you want space in a greenhouse, and it will need to be approved. There are particular services that you can count on, which regular maintenance and repair of the greenhouse systems, pretty basic. Head house areas with, all the amenities and first aid kits, those kind of things. Pest scouting and identification, pesticide applications, all done and carried out by a licensed professional. We can put benches in, we can take benches out of greenhouses. We can arrange them however you would like them to be arranged. We can put in irrigation, we can take out irrigation. We've done that. What's expected of the user is that they purchase their own things. They do things according to the rules and regulations. They keep their space and the common space clean. And more to come, because there will be new forms and new regulations coming along as we get further in. I am in the process of having things posted to the greenhouse webpage. So if you would go to Research and Innovation, there's a tab that's called Research Units and Facilities. Under that is University Managed Facilities. And under that is UNT Greenhouse Core Research Facilities. So all the forms, all the information, the rules will all hopefully soon be posted there. We're working on it. And in the meantime, and anytime, my contact information is here. I'm always available. Please email me, text me, call me. I'm more than happy to help with anything I possibly can. And that is about it for me.
Thank you, Gail.
Thank you.
All right, Richard, if you would like to share your screen, you can proceed.
Okay, thank you. Good afternoon, everyone. Thanks for this opportunity to share this information. Our website is, I've posted the PowerPoints in the chat. So there are some useful links here perhaps for people. So today we're going to talk about these few questions since we don't have much time. We're going to, I don't assume that folks know what high performance computing is. Everyone is familiar with desktop computing, but perhaps not HPC. So we're going to look at that briefly. Next question might be software that I normally use. Would I be able to use these kinds of resources with my software? what kinds of opportunities are available for faculty using HPC systems. So we'll look at that briefly, and we'll talk a little bit about the partnership that we have with TAC, and look at the LS6 architecture, so we have some sense of that is. Then we'll look briefly at the resources that you need to get an HPC allocation request started, the links necessary and the training that you would need to be able to get onto the LS6 system. And lastly, what HPC consulting support is available for LS6 services. Typically, HPC systems for cluster computing are Linux-based, not necessarily always, but they are essentially a massive number of compute nodes connected through a high-speed network. The computing nodes usually share a high-speed file system, and typically, not necessarily always, but typically HPC systems can outperform desktop computing, allowing increased research productivity. For instance, if your research problem size is large and there's a lot of data involved and there are hundreds, possibly thousands of calculations that are necessary, the compute resources can scale correspondingly. And furthermore, HPC systems also provide access to general purpose GPU computing, which uses onboard NVIDIA coprocessor cards, which provide access to thousands of additional processing cores that can be used in serial parallel processing mode. Examples that would involve using GPU or CPU calculations would be, large data settings, scientific simulations, or AI or machine learning and data analytics in general. For example, in the press recently, there's a lot of talk of using AI chatbot large language models to facilitate productivity. Those types of large language models are usually trained on massive, literally thousands of GPU cards. And we have access to those kinds of cards on the LS6 system. Typically, an HPC system will use a batch system queuing. For job execution, you will write a small controller file with Slurm statements that will tell the Slurm manager where your data is, what software to run the algorithms that you might be using. So not all HPC systems use Slurm, but the one on LS6 does use Slurm. While typically these large cluster computing frameworks, users will utilize something like Slurm to do batch computing, there's also opportunities for doing interactive computing on these compute nodes. So you'll be assigned a compute node and you will essentially run a service on a port, and you can forward that port to your local browser. So examples of this might be using Jupyter notebooks for interactive computing, or the popular Python/R IDE, RStudio. So there are other services that you can run on these compute nodes, and you can log into them and use them for interactive computing in addition to using the batch environment. Another notable opportunity on LS6 is to use containers, which is very popular in the bioinformatics circles. Think of containers as basically built software images that can be built on a local machine and then uploaded to LS6 to be used for high performance computing. LS6 has the latest version of that container, which is formerly Singularity, which allows these containers to be built and utilized on LS6. Also popular is using Conda environments with Python. And Conda environments are popular on LS6, and you can build these Conda environments in your user workspace and then deploy them on the compute node. So these are just some examples of popular workflows that people might use on LS6. So naturally, an important question would be, is the software that I'm going to be using, is it going to be able to use these massive resources? Most HPC systems will have software that's optimized to utilize these resources. Linux modules are a system for loading precompiled or pre-installed software applications into the Linux environment. So if further software needs to be installed, you can contact TAC administrators or us, and we can contact them for you to install these other specialized applications. Of note here, specialized applications may or may not be able to use multiple cores or distribute these calculations across computational nodes. In that case, where you have software that's constrained by its architecture to use only a single core or a small amount of memory, then there do exist these small core count queues for either batch processing or interactive use on LS6. So there are opportunities for using software that are not scaled up to using the large core counts or the large memory. Most modern programming language will provide methods for using multiple cores. So perhaps folks that do use Python, which is a popular programming language, there are modules that will provide access to these multiple core and multi-node processing environments. Just to mention a few here, Dask, multiprocessing, MPI for Pi, which would be used for distributing calculations across nodes, are available. And there are another popular programming environment is R, and this also has existing packages for accessing multiple cores and using large data with limited memory. Just to mention a couple of other that are very popular in engineering, in biology, are TensorFlow and Torch for doing AI applications, and they provide functionality for using these multiple cores and multiple nodes. I say some assembly may be necessary because you have to expose that functionality through the necessary function calls. So you can't just throw your existing TensorFlow and Torch applications at these large core and large memory systems and expect them to access those other resources. A little bit about how to get where the LS6 partnership came from, what's necessary to get an allocation on LS6. The UNT Talent HPC cluster that we have had for the last 10 years, it was retired in 2021 under the leadership of Mark McClellan. A partnership with TAC was negotiated, and we became a TAC partnership institution in the summer of 2021, giving prepaid access to the Longstar system for UNT researchers. I have a link there that goes into a little bit more detail about that negotiated agreement. So a thing to note about these prepaid services is that we are getting a really good deal on these services. You could think of TAC as the counterpart to something like AWS, but specifically tailored towards scientific computing. The software environments are prearranged. The environments are specifically designed, pre-designed to facilitate high performance computing. On AWS, it would be on the user or the customer to rearrange these software environments. Also to note here that the network costs for the LSX system, we have a $0 cost for ingress and egress. So uploading and downloading data is essentially covered under our agreement at no cost. Whereas if we were on an AWS platform, we would be spending quite a bit of money on uploading and downloading data. The brief that covers these details is posted in the link below that table. Just a little bit about the LS6 architecture. I won't go into a lot of detail here, but the thing that I want to note here is that these are really large nodes and they have a lot of memory, and we have access to state-of-the-art GPUs. And essentially, these are 128 core nodes that have 256 gigabytes of RAM available to be used, and these CPUs are fairly modern and fast CPUs. So these are large core count nodes, 128 per node, with a lot of memory, and they are very fast processors. So it would be hard to beat this kind of performance on a workstation. Okay, currently we're hosting about 150 users across 40 allocations/projects. One of the things that I would do that I didn't have time to put into this short presentation is the amount of funding across these projects that are external grant funding is something that that we can add to this presentation at a later time. But essentially, this is an approximation. We have more allocations and projects that have come in since I've taken, this is taken from a past report in the last couple of months. So it's not entirely accurate, but it's approximately true. The steps for an LS6 application are posted on our website. If you scroll down at the bottom of the webpage, we've set up some bridge training. There are 3 that you can take in sequence that lead you through going to the TAC website, setting up an account on TAC, and then leading you through the steps necessary to apply for a research allocation. There's 2 types of allocations that we're offering. One is a smaller SU count allocation. It's really meant for users that have never used cluster computing before and are needing small amounts of SUs, standardized units, to meet their research agenda. The research allocations are really designed for experienced users that have, external or internal funding and are involving larger ongoing projects. So when we approve these allocations, we do look for some justification for why these requested SUs are needed, and we are looking to kind of judge or assess whether the research plan will be able to utilize these resources on LS6, but we're fairly lenient in approving these allocations since they are prepaid allocations for UNT faculty. Now, as I said, LS6 is a batch environment, and in this batch environment, there are some limitations, runtime limitations, like there's a 2-day runtime limitation that's fairly rigid. There are some other issues with running 24/7 types of services. So in these situations where LS6 is not really applicable for your needs, the NSF does fund other allocation opportunities. And the way to get access to that is to go to the Access website and start working through creating an account and creating a allocation a request. And so there are 3 tiers on the Access. And those 3 tiers have differing or varying degrees of allocation justification requirements. So at the lowest tier, it's fairly easy to get a fairly large number of SUs available for your research. These Access allocation credits will be awarded, and their turnaround is fairly quick, like within a week or so. So it's a very good opportunity. And once you get those allocation credits, you can transfer those over to other NS-funded systems. Notably, Jetstream 2 is a VM farm that's backed by a cluster computing environment. And there on Jetstream 2, you can run a 24/7 VM, and you can build those compute resources through pre-built containers that are made available on Jetstream 2. I personally, I've used this Jetstream to support a data science course that I teach, and I've had nothing but good results with that system. The kinds of support that we offer, we've got 2 full-time HPC consultants that have, between us, Yuguang and I have probably more than 20 years of experience. We have a dedicated GRA, Beilu, who's a computer science graduate student, available for doing workshops, tutorials, troubleshooting any codes that you are having difficulty with. If you are a bioinformatics professor or informatics researcher and you need help using containers, I've helped people build containers for deployment. So we have quite a bit of experience. If you want to contact us, we have a link set up with ServiceNow that will create a ticket. Your ticket will be attended to rather quickly and will be assigned to one of the 3 of us, and then you'll be contacted. Also, lastly, I just want to mention that TAC hosts a yearly workshop and research symposia in Austin yearly, and it's another opportunity to bring problems and issues that you have to the attention of the tax system administrators. We went last September, and it was a wonderful experience. We get a tour of the facility, and we get to interact with folks on a one-on-one basis, and they have some wonderful workshops that are geared toward using the TAC LS6 systems, not just LS6, but Frontera and Stampede as well. Here are the link with the resources that I used to present here. And lastly, if you have any questions, I'll be here.
Thank you, Richard.
Thank
All
you.
right. Now we'll transfer over to JC and David to wrap up for our materials research facility overview.
Hi, I'm David Jager. I'm manager of the characterization lab and materials research facility. I'll talk somewhat about the basics of the operation of the MRF. We are a shared user facility, primarily supported by user fees, and are underneath the Office of Research and Innovation. We do use a system online. It's a web portal called the Facility Online Manager to manage access to instrumentation in our nanofabrication clean room and our characterization lab. The as we call it, the FOM, provides instrument access and invoicing of instrument usage. Our user base is basically the entire UNT community. We're open to all on community from undergraduates up to faculty members. We also are accessible to external nonprofit and commercial groups, including local community colleges, national universities, and small and large companies up to TI, Texas Instruments, Phillips 66, and such. We do have 3 staff members, myself, Jincho Lee, who is the manager of the clean room, and Saul Sepulveda, who is a instrument technician that floats between both labs. And we also have a director, faculty director, Dr. Raj Banerjee, who's a tenured professor in the material science and engineering department. I'll talk somewhat about the characterization lab capabilities. We, in the characterization lab, host electron and ion microscopy instrumentation, major instrumentation. One is called a 3D atom probe microscope, which allows us to individually detect elemental atoms on the angstrom scale in 3D and build up tomograms from that. We also have a high resolution transmission electron microscope with advanced analytical capabilities, along with a FIB-SEM for doing TEM and atom probe sample preparation using a gallium focused ion beam and a high resolution scanning electron microscope column. Then we also have a high resolution FEG-SEM, which has analytical capabilities for doing elemental chemical analysis and structural analysis of crystallography on the scale from nanometers up to millimeters. And the final electron microscope we have is a environmental SEM, which allows us to look at most samples in their native state, so that we can go from what's called most of the other SEMs, TEMs, the samples have to be clean, non-outgassing, and conductive, while as in the quanta environmental SEM, they can be biological samples or samples that are non-conducting. We also have a surface thin film and X-ray diffraction analysis facility component to us, which composes of a VersaProbe X-ray photoelectron spectrometer, a base ellipsometer, a AFM microscope, and a X-ray diffractometer. Most of the systems in our characterization lab are dated back to 2004, when before it was MRF, this was known as what was called the Center for Advanced Research and Technology, or CART. In that 2013, we transferred over to the VPR's office as the MRF. Some examples of data that is available. This right over here is some atom probe data showing interfacial distribution of elements across these interfaces, and the scale bars are in nanometers, and so we're looking at angstrom level transients of elemental distributions across that. The center portion is high resolution and TEM images acquired on our Tec-9 TEM, and on the right is SEM data from our analytical high resolution SEM, the Nova NanoSim, of I believe this is a bulk metallic glass. top is the morphology, and this bottom is the crystallography obtained from a EBSD detector. And with that, I'll hand this off to JC to talk about the clean room.
All right, next page.
All right, yeah.
There you go. My name is JC Lee. I'm the manager of the clean room. That's the nanofabrication clean room under MRF. Just very briefly on the general specifications, it's roughly 2,600 square feet of class 100 and class 10,000 space. There's a small room where it's the core process of a clean room. It's called a lithography. So we have a small lithography area. The clean room is a controlled environment. We have temperature, humidity, and particle controlled, including the light filter out the UV particle light in the lithography room. And we have instruments for the deposition, thin film deposition, metallization, etching, and the typical lithography processes. There's a few small characterization devices as well, just for on-site measurements. So next slide. So for clean room fabrication processes, the lithography is always the core. We have two types of lithography: the electron beam lithography, which we use a SEM in combination with a pattern generator to be able to write nano size patterns. And the photolithography, we have two systems. One is called a laser writer, and the other one is a mask aligner. And then we have a little bit of thin film deposition, reactive ion etching, which is removing material. And we have OLED fabrication system as well for mainly users from chemistry department, and some basic characterization. And last page. So those are some examples of our user projects. On the left, those two are the E-beam lithography in a very small scale, roughly 100 nanometer scale. And I think on the right, those two examples are from photolithography, which is utilizing UV light for patterning. I think that's it. Thank you.
Great. Well, thank you, everybody. We're running up here on the end of time, but if anybody has a quick question, we can hold for a bit here. All right, well, this will be recorded and placed up on our website. I want to thank the speakers for all giving us their time today, and I really appreciate them describing these facilities. They're great facilities. They're open to all faculty. And I would encourage you to reach out to the folks on this Zoom directly if you want to come over and talk or take a look around. So, all right, well, thank you, everybody. Have a good rest of your day. Bye.
Thank you.
Thank you.